All right, time to continue our fun with functions. Okay, I touched briefly on this the other day when I was showing you on the graphing calculator what a sine wave looked like and how it was operating. Now, you know that we can change these into functions. That's not that big of a deal. Instead of y equals, we just put the f of x in there. And when we take a look at things on the graphing calculator or in a sine wave like this, it kind of gives us a better idea of what is happening with the values. Now, we've been going around in circles, and now what happens if you go and extend that out? Well, this is the path that it would take. And the thing is, once it gets back here, it starts all over again. That's why you see this having basically a periodic wave. That's why they call it a sine wave. And generally, the sine wave is identified as the parent function when it comes to this. Because sine and cosine are exactly the same shape, they just start at different points. So, some of the properties that we're going to have with this. Now, the domain is the set of all real numbers. You can put any number in for x that you want to. The range will only go between -1 and 1. All it can do. Okay? The sine function is classified as an odd function, and it'll have symmetry of the graph with respect to the origin. Okay? Periodic. Every 2 pi, it repeats. Doesn't matter where you are looking at. Okay? And then it talks about where the maximums and minimums happen. Now, just like we were doing before, we can do the transformations of these things. We can squish them together. We can pull them apart. We can pull them up. All kinds of wonderful stuff that goes with it. So, let's take a look at this one. I got the graph of y is equal to negative sine of 2x, and we're supposed to graph this using transformations. Now, knowing exactly what the original sine function looks like is important. So, we're starting here. Okay. Notice how they've got some points that are identified down. Now, it has the period as being 2 pi. So from here to here, it is going to repeat itself. Actually, I'm going to grab this. Put this up. Okay. So, it says the period is 2 pi. So that means that from here all the way over to here, it repeats itself. Okay. Boom. Now, what happens if we're using this idea of a negative? What's that going to do for us? Okay, flips it around, flip it around the y-axis, not around the origin, but over the x-axis. So, if I put pi over 2 and I got 1, that means now I put pi over 2 and I get -1. So that brought it down. Does that make sense? Now, it's got the 2x. So one of the things that you got to kind of keep in mind, if I am putting in 2x, what does that look like at pi? If I put in pi, but now it's 2x, is that going to double something? Well, yeah, because it's multiplication by 2. But that means that I get there twice as fast. And if I get there twice as fast, that's going to squish together the graph. So when you're looking at this, if I put in pi, well, that would be 2 pi, and I get 2 pi out as -1. So when I put in a pi, I should be back here again, okay? because pi should be the same as 2 pi. Get the picture? Because this is going down, hitting it at 2 pi. But now I put in pi, it doubles it up, and I get that at pi. So when you multiply something like that, it has the effect of squishing it. Mostly because you're getting there quicker. Okay? Think of it in those terms. That should help a little bit. Graph of the cosine function. Okay? Cosine function looks differently. It starts up here at 1, at 0. Sine starts here. Goes down, comes back up. It's not that big of a deal. You'll notice that the property of the cosine function is almost identical to the property of the sine function. Okay? They just happen to start in a different place. Domain is all the same. Range is going to be the same. Okay. However, cosine is identified as an even function because it has symmetry with respect to the y-axis. Because it's starting up here, and it had to have been coming up to here, what you see on this side reflects over to this side. And if you take a look at it down here, you can see that a little bit better. Here's 0. It's up here at 1. If I go on negative pi, I end up at negative 1. If I go up pi, I end up at negative 1. So, as we've been talking about this, we said that the sine and cosine graph kind of look the same. They just start in different places. So, sine x is equal to cosine of x minus pi over 2. Let's go back to that for a second here. If I am looking at the cosine wave and the sine wave, okay, all I am doing is taking this graph and sliding it forward or sliding it backwards depending upon how you want to perceive it. Kind of cryptic, isn't it, guys? Amplitude. Where'd it go? Amplitude just goes up. You know, how high does it go up, or how high it doesn't go up? Now, we were talking about the range being from 1 to negative 1. The amplitude affects this. Normal amplitude is simply going to be between 1 and negative 1. But we can increase it, and it'll go obviously higher. We decrease it, and it goes lower. So another one of the formulas that you are going to want to have written down is amplitude, just A, and period is 2 pi over W. We'll talk about how these actually work. Okay. So, if I want to find the amplitude, you'll notice that the number out in front here, that's the A. Amplitude will always be the absolute value. So if I am looking at this value right here, what is the amplitude of this particular function? What? Yeah, just 3. Now, what's the period? Now the period gets a little bit trickier. It's always 2 pi over, and I forget exactly which the name of that particular variable is. But 2 pi divided by whatever number they put in there. Remember how I said that if we put a 2 in there, it makes it go faster? So if I would put a 2 in here, 2 divided by 2, well, that just leaves it at pi, which is what we had seen. If I put 4 in there, that means it's really going faster. So whatever the coefficient on x is, goes in for the period. Now we can learn to graph these things simply by, whoa, that's not good. Wow. What in the world did I do? Just a little sideways today? What did I hit? Rotate. Yeah, I know it. Okay, that's rotator clockwise. Yeah, that's better. Wow, that was what? Fit with what? So I hit that button and it goes and does that. I don't know, fit with. Oh, there it goes. Okay. So again, it's just having the formulas, plugging it in, and going from there. Now, the summary kind of goes over how we identify key points. So, determine the amplitude and period, divide the interval into 4 subintervals of the same length, and use the endpoints to obtain the key points. So, let's get to this. All right. So I'm going to graph this trying to use what the key points are. So let's go back to it and let's take a look at those again, and we're just going to slowly walk through it. So it says determine the amplitude and the period of the sinusoidal function. Okay. So first thing, what is the amplitude going to be on this one? Okay, so amplitude is going to be equal to 2. What is the period? Now the period is going to be equal to 2 pi divided by whatever that W thing is, right? So that means it's 2 pi divided by whatever we see there, which is negative pi over 2. Of course, you can't divide by a fraction. You can multiply by its reciprocal. So we end up with 2 pi multiplied. Yeah, let's do it this way too. This would come up here as negative 2 over pi. So that means that cancels with that. And when I multiply out here, I end up with negative 4. Does that make sense? So that means that at a distance of 4 units, it is going to repeat itself. So, grab this here. What? So, if I start this off, sine is going to be at what? Where does sine start at? Okay, so starts here. And if I count these out here, let's see, I'm going to go, we'll do 1 here, I'll do 2 there, 3 there, and 4 there. Okay. When will it go across the origin again? At 4. Okay. So those two actually repeat. I'm going to put it like this. So those two repeat. Now, when will it hit or cross the x-axis? Okay. It starts here and it goes up, right? Then it comes down and comes back up again, correct? So where will it cross? At 2. So it crosses here at 2. Now, because we've got this idea of one thing that always repeats and it always repeats in the same pattern, we can divide this thing up into quarters, which is what they were talking about of identifying it in 4 different places. So it starts here at 0. We know it goes up, it comes back down again, goes back up, and hits here at 4. That's when it goes back to 0 again. We know it crosses here. Why? Because that's halfway through it. Because it's, a wave that has those properties that it repeats the pattern all the time, and you've got a certain level of symmetry to it. So, what is going to be the largest value that we have coming out for the range? In other words, how far up will it go on the graph? 2. Where will it peak out? At 1, because that's halfway between 1 and 2, so would peak out here. Where is it going to bottom out at? At 3. So it would bottom out down here. So when I'm looking at this graph, I know it's going to follow something like this. Okay? So that's the basics of what that's going to be. But you have to make sure that you take the time to identify where all those wonderful little things are. Okay? And by going and identifying those key points, where does it go across 0? Or I should say the x-axis. Where does it peak out? Where does it valley out? You can go and identify it. You can sketch in the rest of it. Okay? So let's see. Now, we can also go back. Say that I want to go through and I want to find the equation for this particular graph. I need to know 2 things. I need to know its amplitude, and I need to know its period. And I also would like to know its starting point. So based upon what you see here, should this be a cosine or a sine? Cosine, because we got symmetry going across the y-axis, so we'll start off with a cosine. Okay. What is the amplitude of this thing? 3, because we got that going up to here, so we know that this is going to be 3. Okay. Is it reflected across anything? No, it doesn't appear to be, because otherwise this 3 would be down here, correct? So, if I want this, so we know we got f of x is equal to that. Now I got to take care of what goes in here with the x. This is the tricky part. Now, the period here is equal to 1, correct? Period is equal to 2 pi over the w, right? So that means that 1 is equal to 2 pi over that w. So what does w have to be equal to? 2 pi. So w is equal to 2 pi, so that means 2 pi goes up there. And that's it. Seem fairly simple? Okay. I mean, we've been playing with transformations enough that we kind of get an idea of what's going on with it. So I'm going to stop there and let you guys get to work.